Hi, everybody. I'm going to try something a little new and make a video for you so that you can keep going on our 2.2 notes. So these are the wrong notes. Here's what I want. Okay. So yesterday in class, we very briefly talked about what happens when you standardize a normal distribution. So we have this image again that we copied in our notes yesterday, where if you standardize the values in a normal distribution, you end up with the same shape, but now your normal distribution has a mean of 0 and a standard deviation of 1. And this is what's going to happen anytime you standardize a distribution that you have. So, yesterday we used the empirical rule to find the different probabilities or areas that can occur when you have a normal curve like this and you want to find the area under the curve. But that, again, only is helpful if things are getting cut off right at the standard deviation markers. So when that doesn't happen, we use a calculator. Okay, so on your calculator, let me make this so you can see it. So on your calculator, there we go. If you want to do any of these calculations, so you see this VARS button, and above it says distribution, right? So we're going to do second distribution. If you hear some weird noises in the background, that's my cat. I apologize. And then we're going to use normal CDF right there. So 2 is normal CDF. And then if you have this version of the calculator, it'll prompt you to the different things that you're going to type into your calculator. We'll come back to this more in a little bit to see what this is talking about. If you don't have this version of the calculator, you just have to remember that these are the things that you need to tell your calculator that you're doing, which you should remember because you're going to write it down on your paper every time. But just know there's different versions of calculators that will show you different things at this point. So you're going to do second VARS. Normal CDF, we're always going to use CDF and never PDF when we're talking about normal curves. And then you're going to tell the calculator what the lower bound is of the area that you're looking for, what the upper bound is, the mu of the curve, and the sigma. There is a way to do this with table A. It's in your book. I found an image online of table A, and it looks like this. We'll talk more about this in class on Friday, but the book might mention it. I personally find the calculator way easier, but just in case the book mentions it, it is in the back of your book, and we'll talk about it next class. So anyways, when you're doing any of these normal calculations, you need to show some very specific things on your paper. So this goes for the AP exam, but it also goes for any test or quiz or homework assignment you're doing for me. So you're just going to have to do it a lot. And again, it's a good thing because then you'll never forget to do it. So anytime you have to do any type of normal calculations, you're always going to have to draw the normal curve. And you're going to shade, you're going to shade the area of interest. So we'll see that more in some examples down at the bottom. You're always going to have to label your mean and your standard deviation. You're going to shade your area of interest. And then you're going to write down what you told the calculator to do. So you're going to say normal CDF. Your lower bound was whatever the lower bound is. Your upper bound, your mean, and your standard deviation. So these things always have to be on your paper whenever you do any type of calculation with a normal curve. Okay, so these questions are all asking you in this next part to find the proportion of observations from the standard normal distribution. Okay, so remember the standard normal distribution is what we talked about up at the top of the page. It's a normal distribution. My mean is 0. My standard deviation is 1. When they're asking you to find the proportion of observations, they're basically saying what's the area under the curve. Another way of thinking about it is what's the probability that you would get an observation in this area under the curve. So if we have the standard normal distribution and we want to find the proportion of observations that are less than 0.54, so what you're going to do is you're going to draw this standard normal curve. Your mean is 0, your standard deviations are 1. And then you're going to show where approximately 0.54 would be on that curve. And then since it's less than that, we're going to shade that. Okay. So in your calculator, you're going to say, so less than 0.54 is going on and on and on to the left forever, basically. Okay. So you want a very small number. So that's why we just use -1 times 10 to the 99th power. That button is right there. That times 10 to the whatever power is right here. So your second and then your comma button. So then our upper bound is going to be 0.54. Again, we're using the standard normal curve. So our mu is 0. Sigma, our standard deviation is 1. And it'll just kind of show you, it'll verify like what you typed in. You hit enter again, and it's telling you 0.705. So what that means is that about 70% of the area under the curve is less than 0.54. So, I mean, if you think about it, it should make sense. You always want to just double check that you got an answer that seems reasonable. So if it was anything less than 0, that would be 50% of the curve. Between 0 and 1, we have 34% of our data. So if you take, a little bit more than that, that would be 17%, which would get you up to 67% total. And 54 is even a little bit more than that. So this seems pretty reasonable. So you should just think about that when you're doing these types of problems. If you're doing this problem over here, we have greater than -1.12. So again, you're going to draw the curve a second time. However many times you're doing this, you're going to draw a curve for each part. So here's the same exact curve. Now, -1.12 would be in between -1 and -2. Maybe a little bit closer to, not maybe, a little bit closer to -1 than -2. And then we're going to shade everything to the right. So then our lower bound is -1.12. Our upper bound is positive 1 times 10, to the 99th power. Our mean is 0. Our standard deviation is 1. And in our calculator, again, I'm going to do second vars. Normal CDF. Okay, so now my lower is -1.12. My upper is something very, very big. And then the same values there. Okay, so that's how we get the 0.8686 value that is on here. So again, even though you're getting all this information from your calculator, you're going to draw the normal curve. You're going to figure out the portion of the normal curve that you're going to be solving for. You're going to mark that area under the curve. And then you're going to show the values that you're typing into your calculator and where you're getting this number from. Okay, so C and C is similar. D is in between two values on your normal curve. So it's a little bit, I don't know, it's the same idea. It's just one of your end boundaries isn't, something very, very small or very, very big. It's just two values on the curve. E is phrased in a little bit different way, but it's the same idea. E is saying we want to know the area under the curve that's within 1.5 standard deviations from the mean. So what that means is we want 1.5 below, 1.5 above. So then your lower boundary would be negative 1.5. Your upper boundary is positive 1.5. Okay. All right. So something like this question here. We have a distribution of test scores that is approximately normal. Joe is scoring in the 85th percentile. So remember, the 85th percentile means 85% of scores are lower than Joe's. Okay. So how many standard deviations above the mean did he score? So in this case, we don't know the number of standard deviations here, but we do know the area under the curve. Okay. We know that wherever his score is, 85% of the students are below him. So the area under the curve to the left of him is 85%. So in this case, when you know the area, what you're going to do is you're trying to find whatever the z-score would be. Okay. Because that's the same thing as how many standard deviations. So when you know the area and you're trying to find the z-score, you're going to use a different command in your computer called inverse norm. So in your calculator, if you go to second vars, inverse norm is then the third one right there. So we know the area is 0.85. Again, we're on the standard curve, standard normal curve. And so he is 1.04-ish standard deviations above the mean. Okay. So that means his z-score is about 1.04. When you're doing this, when you're using inverse norm in your calculator, it's always looking at the area to the left. So you just want to be really careful about when you're doing this, which is one of the reasons why we always draw the curve and shade it, to make sure that we know that we're looking at the correct values with our calculator. And then you also want to make sure that you get something that seems reasonable. Again, to the left of 0 would be 50% of the data. From 0 to 1 standard deviation, that's another 34% of the data. So that's 84. So it makes sense that he's just a little bit higher than 1 standard deviation above the mean. And then the last example here is in a normal distribution, Q1 is how many standard deviations below the mean. So you need to translate this into a percentile. Okay. The only thing that we're going to be labeling on our normal curves are percentiles, which are then areas under the curve, or standard deviations or z-scores. So this is 25% percentile. So it's going to be 25% of our data to the left. So again, we do inverse norm. We would do the area under the curve is 0.25, mu is 0, sigma is 1. So it is negative 0.6745 standard deviations below, so I guess I should say 0.6745 standard deviations below the mean. So the rest of the notes for today are just to do this one example with Rafael Nadal, and to also do this one with Clayton Kershaw. So I'm going to post these notes online on Google Classroom, whatever it's called. Try them on your own and then look at the notes and see how your notes compare. But hopefully the calculator stuff is clear. There's also information in the book about it in case I was not clear. And I'll see